All right. So we're now talking about introduction to statistics, and I'm not gonna lie, this entire section is pretty boring. Um, we basically just need to learn a lot of vocabulary to be able to talk about the rest of this. So unfortunately, like I said, these next couple of videos are going to be relatively boring, but definitions are very important. So especially if you just do not like the math part, maybe this next couple of videos are actually going to be for you because it's not a lot of math, as it were. It's a lot of just definitions and understanding statistics in general. So maybe there's hope for people who, you know, don't like math. All right. So, um, there we go. All right. So, statistics. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. So it actually is a science. So technically, statistics is not a great example of math. It is a science. We will talk about hypotheses in this class at the end of the semester. So in addition, we must report a measure of our confidence in our results because we do not have 100% certainty. Our answers are correct. And this is, again, why it's not exactly a great example of math. So again, some people who love math, they actually hate statistics because statistics is very different. And some people who hate math love statistics. Because typically in math, we are 100% certain. So let's think about this for example. If you go to a community college and you want to know the average age of the students, how could we figure that out? How can we figure out what the average age of a community college students are? Well, one thing you could do is maybe go to the registrar and get a list of all the students. Right? So you look at their ages, you add up all the ages, divide by the total number of students, and that's how you get the average, right? But let's say that the registrar doesn't give you it. Let's say that that's like a, you know, uh, private thing, or they don't have the information somehow. There's no way to look up it. So what's a different way that we could actually figure out the average age of students? Well, what we could do is we could just go to a group of students and take their averages. However, if we're not looking at everybody, if we're just looking at a group, a small group of students, are we going to be 100% certain of that average? No, we're not, right? In actuality, you may get very different results for different groups. So let's think about this. We can give us a little more space. It's very possible that if you're finding these groups with classrooms, right? You go to a classroom and you say, hey, what's the average age of everybody? So if there's a night class or a Saturday class, right? It's probably more likely that the average age is higher, right? Typically, the reason why a student would take a night class or a Saturday class is because they have a job, right? So these students probably are going to be in their mid to late 20s, all the way to their like 40s, 50s, 60s, right? It could be people who are trying to get a second career going. Could be people who are trying to get a first career going, right? Maybe they were a stay-at-home parent and now they want to get out of that. So I guess that technically would be a second career because the first career would be a stay-at-home parent. So apologize. As opposed to if you had something on a Wednesday afternoon. So if there's a Wednesday afternoon class, right? It's probably going to be composed of a bunch of 18 to 20-year-olds. Probably, right? At a community college. These are probably going to be the students who don't have to work. They're living at home. Their parents are paying for college, right? So all they're doing is taking college classes. Now, doesn't mean that that an 18 to 20-year-old wouldn't be in a night class. It doesn't mean that an older student wouldn't be in a Wednesday afternoon class. But typically this, at least in my opinion and what I have seen in my classes teaching these different types of courses, this is typically what happens, right? So regardless, remember, different results for different groups. So we cannot be 100% certain. So that's why we have to have some sort of confidence in there. So we're like 90% certain that this average is going to be, where we are. We're 70% certain. And we'll talk a little bit more in the end of the semester where those numbers come into play and how we can actually be some percentage certain. But the most important thing is that we are not 100% certain of these statistics because we're only looking at a group of people. We're not looking at the entire population. All right. So let's do the next thing. The information referred to in the definitions above is called data. So the things that you actually collect are data. These are facts or propositions used to draw conclusions or make a decision. So they describe characteristics of an individual. So what could be some characteristics? If we're talking about an individual is a human, what would be some human characteristics? We could say height, weight, IQ, hair color, right? We could say the number of hair follicles. I'm not exactly sure how to spell that. Follicles. That's probably right. Good. But individuals don't have to be humans, right? We could talk about cars. What's the characteristics of a car? Maybe the engine size, the number of doors, whether it's an automatic or a manual. It could be the color of it, right? The make, the model, all that kind of stuff. Good. So yeah, you don't just have to take a study on humans. You could take it on anything, right? Chairs, rabbits, cars, anything like that. So, important thing is that data has to vary. So data is a plural word. It's multiple. So multiple data is. So you don't say datas. Apparently, you just say data. I may interchange that, but there you go. So, for instance, we're not going to do you only do surveys on data that vary. So, for instance, would it be a very interesting study to try to answer the question, how many how many hearts do humans have? Would that be a very interesting study? No, right? Most humans have one heart. I mean, there might be an anomaly, right? But typically, that data is not going to vary. Everybody's going to have the same number. So that's going to be a very boring study, and we wouldn't want to do one on that. Maybe we could do something on the nature of IQs in humans, right? Now, IQ does vary. So that might be something interesting to check out, right? We could even talk about, so this could be how it varies between people. We could even talk about data that vary within the same person. So how does different amount of sleep affect one person, right? That data would be different each day. Maybe you can hit a target 15 times one day, but only 3 times another day, right? So maybe that would be because of sleep or something. Good. All right, so here's the big vocabulary section. So again, I apologize, it's gonna be super boring. We'll get through it, it'll be great. So population is the entire group to be studied. So this is everybody. And this is going to be a very important thing to know throughout the semester. What is your population? That it may seem pretty obvious, but especially when we start talking about samples, those two ideas can get a little confusing. Speaking of samples, a sample is a subset of the population being studied. So the sample is the small group that we're actually looking at from a giant population. And this is why this can get a little confusing, because typically the number in your sample is going to be the bottom number when we look at probability. But we can keep moving. We'll talk a little bit about that later. An individual is a person or an object, right? We talked about cars and humans. That is a member of the population being studied. Statistic is the numerical summary for a sample. So if you're looking at a statistic, that's going to be the numerical summary of samples. So this can be like probability, for instance. That can be a type of statistic. Descriptive statistics consists of organizing and summarizing data. So typically these can be described through numerical summaries, tables, and graphs. We'll talk a little bit more about that in the chapters to come. Inferential statistics, however, uses methods that would take the results from a sample and extend it to the population. This measures the reliability of a result. So, actually, the entire purpose of statistics is that you are trying to use this sample to make an assumption about the population, right? So if we go back to our first example ever, right, when we talked about the average age of community college students, this is what's happening. You take a sample of students, this group of students, and you try to use inferential statistics to determine the population of everybody in your community college. Since that's statistics, we'll be talking about that a lot this semester. So I'll be able to remind you over and over again. A parameter is the numerical summary on a population. So a sample is a numerical method of a statistic. A population is one for a parameter. So if you notice SSPP, hopefully that can help you remember. So let's look at an example. So problem number 1, determine whether each statement is a parameter or a statistic. So I gave you those word problems handout, so we can go through these. So if you'd like, try to go through these yourself. So pause the video, try to see if you can figure it out on your own, and then come back and watch me do it, see if there's the same answers. So among the flights included in the sample of flights, 21% arrive late. So is that going to be a parameter or a statistic? Well, it actually told us sample, so this is going to be a statistic. There are 50 state capitals in the United States. Is that a parameter or a statistic? Well, there's only 50 state capitals, right? So that's all of them. So since it's all, that's the entire population. So this is a parameter. A study was conducted of all 2,223 passengers aboard the Titanic when it sank. So again, since it's talking about all of the passengers, that's the population. So this is a parameter. In a study of 150 households, it was found that 74% had high-definition TVs. So, notice this is not what we're going to be looking at. We're not going to say, oh, only a percentage have high-definition TV. Because, of course, only that works. This is actually what we're trying to find. So we're trying to determine, is this a sample or is this a population? 150 households. Well, there's definitely way more than 150 households, right? In the nation, in the state, in the county. So this is not a population. This would have to be a sample. And we can see that because there are definitely way more than 150 households. So this has to be a statistic. All right. We're going to pause right here and come back in the next video.